Good morning, everyone.
Alright, so hello, my name is Ricardo Guizar, and today for this project we're going to be doing the fishbowl first. This measurement. That's the first one. First cup on the bucket. Scoop. Okay, so right now we're doing the matching part with the grabs and the bottles themselves, and here are our final results. So for the ink bottle, we deducted it would be like graph G, as it goes constant up to this point. This could represent the line that is present right here to here to here. It goes quicker as we start decreasing in volume right here. That's quick right there, but then at the end it goes really quick because of the super small decrease, but it's kind of constant. That's our last graph right there. For our evaporating flask, it would correspond most likely with graph A, as we saw in our other graph with the evaporating flask. We see that it starts going quickly here, around this area right here. That's the quick right there, quick. It starts going slowly around this area right here. So that gives us like a kind of flat line. And then towards the end it starts going a little bit quicker. This right here. But at the end, as we can see, there's a constant, very quick increase because of the lack of volume. That's our last line right here. Now for our vase, it will start off going quick. We start from here and we start going here, so it's quick. No, slowly. It starts going slowly like this, but as we go going quick from around this area, so right here. But as we start expanding the volume, we start going slower, so that will eventually give us our flat line right here.
Okay, so for the other three, the conical flask, we decided it would be graph D, because as the volume starts wide and it's decreasing, it starts decreasing, so we see the volume going constantly increasing, but then at the end it starts decreasing, staying figure on the volume as it's more narrow. And so we decided to go with D. For the bucket, we decided to go with A, as the figure of the bucket is constant, but it's not kind of constant, like it's a little bit wider, but throughout the whole shape it's constant. So as we see the graph, it's decreasing, not decreasing, but like it's just like increasing, but it's just constant. And then at the end, as it gets more wider, it just gets more constant as a horizontal line. And for the pledge funnel, we just had to go with B, as first we increase, shown here, the narrowness of the figure, like it will increase quite rapidly, and as the volume widens, like increases, that will make the volume more slower, making it take more time to fill up. Go.
Okay, so for our last part, which is step 3, we gotta sketch a model for the remaining of the graphs. So for example, if we take graph C, we see that it's a very constant slope, but it's quickly increasing. That gives us to detect that it'd be something similar to the plunge funnel, where it has a very small area and it's kind of narrow like that. But we see that the slope decreases, but it's still somehow constant. That tells us that the figure is constant, but it's larger than what we have at the bottom. So it would be something like this, similar to that right there that we have, like a little T shape. Now for graph F, it's quite the inverse. It starts going off quickly. No, it starts going off pretty constant in a shape, but then at the end it seems to have a rapid increase that's still constant. So in this case, it would be the other way around. We would have like a square shape at the bottom and a very narrow place at the top right there.
So for the last one, for the H graph, we decided to go with this figure, as in the bottom, it's the volume of it is slightly larger. So as shown here, it's gonna be increasing but slowly, and then right here in this part it increases, so this part is more narrow, increases rapidly, and then again we go back to like the base, it widens, so the volume increases, so then it will go slower, and the narrow on the top will increase the volume rapidly.